Okay, this question comes from Calculus 3, and it is a error question in which we're dealing with 120 volts with 2000 ohm resistor, and of course you are given that P is equal to E squared over R, where E is equal to the voltage, which in this case is 120. We're not really concerned with the 120 because what we're dealing with is the errors. At R, which is your resistance or resistor of 2000 ohms. Our relative errors in respects to E and R are dE over E magnitude is equal to 0.03, and that comes from, I'm sorry, not 0.3, 0.7 right here, and dR over, over R is equal to 0.06, which is there. Now the first thing we're going to have to do is find the total differential, and the way that we do that is dP is going to be equal to the partial derivative of P over E in respects to E, dE, plus the partial derivative of P in respect to R, dR. Now when we do that, we're going to use the quotient rule on this one since it is a fraction, and we're going to do dP is equal to, and we will take the partial derivative in respects to E, so that means we'll have the denominator times the numerator prime minus the numerator times denominator prime over denominator squared, and that's in respect to E, so that means that we're going to make R be the constant, and in the plus we're going to do the second one, which is in the derivative of P in respect to R dr would be the same thing, only that you're going to treat E as the constant, so that would be the same thing, E squared prime minus E squared R prime over R. And when you do the calculus, you're going to basically get R dP is equal to R times E squared prime minus E squared R prime all over R squared. That's the second part. I forgot to write down the first part. The first part comes out to be 2E, let me just write it up here, 2E minus over R minus E squared over R squared. And basically when you get through with everything, you're going to come out with 2E over R dE minus E squared over R squared dr. And that is your total differential. Now to get the relative error, we're going to have to divide the total differential by P. So let's rewrite our total differential and divide it by P. So the total differential is equal to 2E over R dE minus E squared over R squared dr. And we're going to divide that by p, in which p, remember from the beginning of the problem, p is equal to e squared over r. So we're going to divide by e squared over r. I'm doing the algebra, and I'll just go ahead and multiply by the reciprocal. dp over p is equal to r over e squared times 2e over r dE minus r over e squared times e squared over r squared dr. And when you do the algebra, you're going to cancel these out. That's going to cancel here and there. And these are going to cancel. This one's going to cancel. That one's going to cancel. And we're left with, when we get through with everything, we're going to be left with dp over p is equal to 2 over e dE minus, looks like we got 1 over r dr, in which we can rewrite that as dp over p is equal to 2 times dE over e, which is the relative error in terms of voltage, minus, let's see, 1 times dr over r, which is your relative error in reference to the resistance. So now it's just a matter of plugging and chugging. dp over p is equal to 2 times, or dE over e from the beginning of the problem is 0.07, so we plug that in there, minus, and we have to make it add because of this of the original formula to add the two together, so that would be negative 0.06, so that would be 1 times negative 0.06, and we have the final answer of 0.14 minus a negative 0.06, and if my math is correct, that comes out to be 0.20 or 20%. And I hope that helps.